Hello. Want to go see a black hole? You're going to like it so much you won't be able to escape.
We can't see black holes.
Wait, what?
I thought we went over this in 7th grade. You're embarrassing us.
Well, sorry. Let's just start from the beginning.
Fine. Due to some technical difficulties, we'll have to explain what a black hole is all over again. I apologize to those who were in our 7th grade class.
Oh, it won't be so bad this time.
Hush yourself.
So, how did black holes come about?
Don't you remember anything? Einstein first proved that light could be affected by gravity in 1915 when he developed his theory of general relativity. The term was coined in 1967 by John Wheeler, a professor from Princeton. The actual physical black holes usually form from the deaths of stars that are around 20 solar masses.
Aren't you missing something? A star just suddenly decides to be a black hole?
I don't think so. I don't remember though.
As I recall, once a 20 solar mass star runs out of fuel, it will stop producing energy by nuclear fusion. Since nuclear fusion no longer provides pressure to counteract the pull of gravity, a star will result in a supernova where the outer layer explodes in a ball of hot gas.
Hot? Hot like lava or hot like Kate Upton?
Figure it out, Curtis. Anyways, after the gas from the exploding star stops expanding, it collapses towards the center because the gravity from the star's core pulls the gases towards it.
So this is how the singularity, or the center of a black hole forms? I guess all that gas from a supermassive star will explain the gravity of a black hole. Black holes are really just stars compressed to the size of New York City.
I forget again, how strong is the pull of a black hole's gravity? Is it stronger than my vacuum?
The gravity is so strong that once light goes beyond the event horizon, the so-called surface of the black hole, it can no longer escape.
Wait, I'm confused. If something does not pass the event horizon, is it possible to escape the gravity of a black hole?
Yes, however, black holes also bend space around it. This is commonly observed with celestial bodies. Space is bent around stars, planets, and moons due to gravity. Even the Earth bends the space around it.
So then doesn't that also mean that black holes can bend light? Because by bending the space that light travels in, doesn't light have to travel around bent space as well?
Interestingly enough, not only is space and light bent, but time is also affected by black holes. Once again, this is due to the immense gravity of a black hole. To an observer, an object falling into a black hole would never actually fall in because the light will be frozen in time. So you were right when you said that people who are sucked in can never escape.
Yay, I was right.
So, what types of black holes are there?
There are stellar mass black holes. They are 10 to 25 times the size of our sun. There's about 10 million to 1 billion black holes that are of this size in the Milky Way.
That's a lot.
There's also another type of black hole which I don't quite remember.
I think you're talking about supermassive ones. Supermassive black holes are usually located at the center of galaxies. Our own galaxy, the Milky Way, has one in the center of it in a region called Sagittarius A. These types of black holes are millions to billions times the size of our sun. One theory states that as black holes eat more and more stars, they grow bigger and bigger until they drift to the center of the galaxy and merge with other black holes to form a supermassive black hole.
Never thought being large could be a good thing. I want to have a galaxy spinning around me, or at least I want to be a stellar mass black hole.
What you don't want to be is a primordial black hole. These are black holes equivalent to the size of asteroids or less. This theory by Stephen Hawking states that these primordial black holes were created during the Big Bang. The reason that there is no evidence for them is because of Hawking radiation.
Hawking radiation is simply when black holes emit particles due to quantum effects near the event horizon. This means that the black hole loses energy and mass. For tiny black holes like the primordial ones, Hawking radiation will cause these black holes to vanish the minute they form.
Much larger black holes are also affected by Hawking radiation. Since they're so big and are constantly sucking in more matter, it would be rather rare for them to die. Even if they stopped sucking matter, it would still take about the age of the universe 10 times 10 to the 60th power for the black hole to evaporate.
How are black holes detected if even light can get sucked in?
Since scientists can't detect black holes using any kind of light directly, black holes are detected by observing the objects around them. When a black hole passes close enough to matter, the matter is drawn towards it in a process called accretion. As the matter gets sucked in, it heats up and releases X-rays into space, which can be detected. We have our very own black hole detector here.
Curtis, what's that on the detector display?
I think it's a black hole. Run for your lives!